Cool. Not too bad. Let's go ahead and do the next couple of problems. All right, so this is a plus b squared is equivalent to a plus b times a plus b, which will give me a squared plus 2ab plus b squared. All right, so if a squared is 25, so I'm going to show it a little bit differently. A squared is 25. So if I take the square root of a squared, that means a can be either positive 5 or negative 5. Okay. And b squared is 4. So b squared is 4. Square root of b squared, square root of 4. So that means b can be positive or negative 2. So it can be 5 plus 2 squared, which is 5 plus 2 times 5 plus 2. 5 times 5 is 25. 2 times 2 is 4. The 5 times 2 is 10. There's 2 of them, so we get 20. I could do negative 5 and positive 2, which is, well, negative 5 plus 2 squared is negative 5 plus 2 times negative 5 plus 2. And negative 5 times negative 5 is 25. 2 times 2 is 4. Negative 5 times 2 is negative 10. There's 2 of them, so I get negative 20. And right here, I can do a positive 5 and a negative 2. Positive 5 minus 2 squared is 5 minus 2 times 5 minus 2. 5 times 5 is 25. Negative 2 times negative 2 is positive 4. 5 times negative 2 is negative 10. There's 2 of them, so we get negative, so minus 20. And lastly, both of them could be negative, so negative 5 minus 2. Squared is negative 5 minus 2 times negative 5 minus 2. Negative 5 times negative 5 is positive 25. Negative 2 times negative 2 is positive 4. And negative 5 times negative 2 is positive 10, but there's 2 of them, so positive 20. Cool. And I think you'll get the point on this one, so I'm going to go to the next page. All right, so this is completing the square, but this time we're missing the third term. Like we have the first term, we have the second, we have the a squared, we have the 2ab. We're just missing the b squared here. So what I'm going to do is, all right, so we know that a squared is 9 in this case, right? I'm going to move this slightly over, actually. A squared is 9. So if I take the square root of a squared and square root of 9, I get a can be positive or negative 3. Okay, cool, not bad. So we know that a is positive or negative 3. So we know that this can be positive 3 or it can be negative 3, right? I'm just gonna wait for now. And I know that 2ab is 2ab is 24, like this. I'm going to do it in a different color. Is 24, so 2ab is 24. But I also know that a can be positive 3 or it can be negative 3. I want to make it positive 3 in this case. So I get 2 times 3 times b equals 24. 2 times 3 is 6. So I get 6b equals 24. If I divide by 6, b is 4. So when a is 3, b is positive 4. So that means b squared is 16. Because 4 times 4 is 16, right? Or plus 16. Now, let's see if this works with the negative version, I guess. So I'm going to do this. I'm going to make 2ab red this time. So 2ab is 24 still. But instead of this, instead of making a 3, I'm going to make a negative 3. Two times negative 3 is negative 6. Oops, that looks like a B. Divide by negative 6. And I got, or I have B equals negative 4. So, if A is negative 3, then B has to be negative 4. So it will say negative 3 minus 4. Now let's offer some proof that these are the same. Okay? So let's do this in purple. So I'm going to write 3 plus 4 squared should give me 9 plus 24 plus 16. You know what? I'm just going to show it here instead of, I don't think there's enough room horizontally. So 3 plus 4 squared is 3 plus 4 times 3 plus 4. So I'm going to prove that this is the same as these. And I get 3 times 3, which is 9. 3 times 4, 3 times 4, which is 12. 4 times 3, which is 12. And 4 times 4, which is 16. I'm going to combine the two middle terms, and I get 9 plus 24 plus 16. So basically, let me rewind a little bit. I'm given an incomplete perfect square trinomial. I was just given 9 plus 24. And my goal is to figure out what I can put here. What I can put here that would make this a perfect square. I want to figure out what I can put in the blank to make it a perfect square. I can put in a 16 because if I put in a 16, I can express it as 3 plus 4 squared, or negative 3 minus 4 squared. Let's do it one more time. Actually, let's just jump to example 6. I don't think I'll need example 5 for now. So we know that a squared is 25. And if I take the square root of a squared and 25, I get that a can be a positive or negative 5. Because positive 5 times positive 5 is 25, and negative 5 times negative 5 is positive 25. Now I know that my 2ab is negative 30. And I know that my a that I want to use first is positive 5. So I just have to figure out what b is. Because once I know what b is, I know what b squared is. Like, basically, that's the whole point. Is I have to figure out what b is, so I know what b squared is. So I use the 2ab to figure out what b is. So 2 times 5 is 10. And I divide by 10. b equals negative 3. So when a is 5, b was negative 3. And this negative 3 times negative 3 would give me a positive, I want to put that in blue, a positive 9. Now let's try the other one. So I'm going to do red this time again. So 2ab was negative 30, or is negative 30. I feel like that 9 really bothers me for some reason. Okay. Better. So the 2ab is negative 30. This time I'm going to say that the a is negative 5. And we'll find out what b would be if a was negative 5. So 2 times negative 5 is negative 10. Divide by negative 10. Oops, I should probably write that a little nicer. Okay. I don't know why I'm having difficulty writing. Okay. So that means b is positive 3. So if a was negative 5, then b would be positive 3. And so, and then the positive times positive would also give me the positive 9, right? Let's go ahead and prove it. And it doesn't matter which one you prove. I'm going to prove this second one. Negative 5 minus 3 squared should give me a perfect square. So that's negative 5 minus 3 times negative 5 minus 3. And negative 5 times negative 5 is positive 25. Negative 5 times negative 3 is negative, or positive 15, right? Negative 5 times, oh, that's what I did wrong. This is negative 5 plus 3. So plus 3, plus 3, plus 3. Okay, so negative 5 times negative 5 is positive 25. Negative 5 times positive 3 is negative 15. Positive 3 times negative 5 is negative 15. And positive 3 times positive 3 is positive 9. I'm going to combine my two middle terms, and I get 25 minus 30 plus 9. It is a perfect square. 25 minus 30 plus 9. 25 minus 30 plus 9. Okay, so we wanted to prove that 25 minus 30 is a perfect square. And that perfect square can be expressed as negative 5 plus 3 to the second power. All right, that's it. Thank you.